Alright, so if you don't mind a little background noise, this is going to be not the best prepared video, but I'm going to go over some of the problems that were missed last semester, or last summer, sorry. Some of the most missed problems. Let me see if I can get the whole screen to show in here for you. Number 3 and number 16 were both missed by 5 people, and then that was the most. And then there were some problems that were missed by 4, and then some that were by 3, and so on. Okay, so here's the question for this problem. Now, by the way, this would look like number 7 in the book, so it'd be section 3.3, number 7. There's video, there's an animation, you can watch these things. I'm going to go ahead and show you the first way I would do it if I was doing this problem on my own. So I'm assuming I'm using a device or a computer that can play Flash. So I'd read through the problem, go ahead and read through it, and then I would look at my data set and open it immediately in StatCrunch. And of course you'll be able to use StatCrunch during the test. You'll be able to use the TI-83 calculator. When I put the approved testing material, you'll notice that there's StatCrunch material, TI-83, Excel, there's the formula sheets, which you could then do it by hand, so to speak. And incidentally, I know that we use the phrase by hand quite a bit, and sometimes I don't think we're being accurate. When we say that we're using it by hand, I'm pretty sure we're still going to use some sort of calculator, like minimally something like this, to find our sum and then divide by our count, get the average, and then find our deviations and so on. Anyway, so I'm sure we're not really doing it all the way by hand, but there's a better way than using just this kind of a calculator. There is the TI-83, which I'll go to next. Alright, so if I have the homework open and I can just open the data set that they've given me inside StatCrunch, then I can run the whole question here. They ask me for the range. Well, it's kind of hard to tell what the range is when it's not sorted. So I could actually sort the data by going data. This would be a column selection. So let's see here. It says row. And I do not see my column selection. So let's see. Oh, there it is, column. And then you can tell I do this often. I do it so infrequently that I'll have to just get back to you on just sorting the data. Okay, there it is. It is under data. I thought I was going to first have to choose a column operation, but it's already there. It says sort. So I can just choose sort, select the column from this window, and then say how I want it sorted by ascending or descending order, and then compute. And it made another column for me, but it titled it sort, so it's the sorted version of that list. Now then I could just take the max minus the min, and that's making reference back to doing by hand. That's kind of the doing it by hand, but I wouldn't even do that by hand. I'd really still at least use a calculator for this. So 18, I can stick in 18. There's my range. But anyway, like I was saying, it's kind of a waste. I don't do it that often because if I'm going to find the sample variance, if I'm going to find the standard deviation and other things, then I might as well just do stat, summary statistics by column. Okay, so choose stat, summary statistics, column, and then choose the column. I'm choosing the unsorted column to show you how functional this is. And then I'm going to choose what I want it to tell me. So it actually already has the standard summary statistics listed right here and highlighted and brought over to the column of what's going to be done, the operations that will be used. But I can select more if I wanted more. I can choose the sum or any of these other pieces. I'm just going to go ahead and go with the regular. And I'm just going to say compute. So what you'll see here, let me see if I can flip back to that page. Cannot show them both at the same time unless, no. The variance will be listed. The mean is listed, although they're not asking for that. The range, there's that range we already got of 18. And then there's the standard deviation. Now, what we should know by doing it by hand at least once, do maybe number 2 by hand, and then do this with with StatCrunch or StatDisk or TI-83 or Excel, we should note that the standard deviation is the square root of the variance. So if you just do all that stuff inside the standard deviation and don't take the square root part, then you're using the variance. And we should also start learning their notation. A sample variance is denoted by S, just regular, I'm sorry, S squared, just regular S squared. So we can verify right here that if you took 59.5 and found the square root, we'd get 7.71 blah 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 blah. So 7 and 71 hundredths, assuming that they're going to round to the nearest tenths, 7 and 7 tenths. All right, don't put that in because right now they're asking for the variance, so that's 59 and a half. Okay, now, and by the way, if you're trying to save time on homework, I noticed that I assume that some of you guys are still clicking buttons. You can hit enter for a lot of these functions. Okay, so this one was 7 and 7 tenths. I'm going to go ahead and just hit enter again, hit enter again to continue. What should the value of the standard? What should be the value of the standard deviation? Ideally, the standard deviation would be 0 because the measurements should be the same. Oh, I guess I should read the question because it's only going to be 0 if they are the same. Why would they be the same? I don't know. It depends on the context of the question. Ideally, the standard deviation would be 1 because all measurements would be the same. Nope, that's not. That statement is entirely untrue. If they were all the same, their standard deviation would be 0, so that doesn't even make sense for it to be 1. Ideally, the standard deviation would be 1 because this is the lowest standard deviation that can be achieved. Absolutely not true. If all of them are 127, then the standard deviation is 0 because there is no deviation from the average. The average would be 127 also if they were all 127. And there could be 100 numbers there. If they're all the same, the standard deviation is 0 because it measures how far they deviate from the mean. There is no way to tell the standard deviation what the standard deviation should be. I don't know. It's either A or D. Let's go to the context of the question. 6 different second-year medical students at Bellevue Hospital measured the blood pressure of the same person. Ah, okay. So it's the same person. We assume that their measurements should turn out to be the same. Now I can read on. The systolic readings are listed below. Find the range, variance, standard deviation of the given sample data. If the subject's blood pressure remains constant, so now they're even reinforcing the idea that since this was a measurement of the same person just by different medical students, we would expect them to be constant in their measurement. Correctly apply the same measurement technique. What should be the value of the standard deviation? Well, it should have been 0 should have been the standard deviation because they should have all been the same. Now obviously they didn't turn out all being the same, so you go back to your students and you talk to them about how they were doing their blood pressure check and how they were checking for blood pressure and reteach them or whatever. Anyway, I'm not that concerned about that. I'm not teaching any sort of medical techniques or anything like that. Now, I'm going to make another video of this using the exact same numbers, but I'll do it by hand. In fact, I was going to say maybe you could just stop here, and I will continue only if you want to see it in Excel or the TI calculator. I will do that. So here's the procedure repeated for the calculator first. Turn on your calculator, clear whatever's on, go ahead and exit. You click Stat, choose 1, or just hit enter because it's already on 1. Choose some lists where you'll put the data in. I'm going to first clear my list. I'm going to go up and hit clear, then hit enter. You can't see enter, it's off the screen, but that will clear. Do not go up and hit delete. If you hit delete, you just deleted the entire column. See, it's gone. Now it goes from list 1 to list 4. Don't worry, there's an easy fix to this. Hit stat, go down to the setup editor, or just hit 5, and then hit enter. You just fixed that problem. You brought your lists back. So stat number 1, and there they are. They're still filled in, but they're at least back. If you want to clean them quicker more quickly if there's lots of them, you can do clear list, and don't select a particular list. Just hit all. Just hit clear. Or I take that back. I guess on the TI-83 you do have to choose the particular ones. So I will choose list 2, comma, then you hit second number 3, and that gives you list 3, comma, hit enter. Okay, now that cleared them. There is another way. I think it's maybe hitting second list and going under math or something. I don't know. Doesn't really matter. So once you're in the lists, to edit, put in your numbers. 127. I'll just go ahead and go fast. Now since I have 6 numbers and I'm on this 7th entry with nothing in it, or in other words I'll go back up, I've got 6 entries filled. I feel comfortable that I got them all in. Make sure you have them in correctly, because if you go in, there's a saying, crap in, crap out. You know, if you put the wrong stuff in, you get out the wrong things, or if you run the wrong tests, you get the wrong information. You draw the wrong conclusions. All right, so from here I can exit this screen. I'll just go ahead and clear the whole home page. I hit stat, I arrow over to calculate, and then I'm going to run the single variable statistics. I've got a single data set, and I'm going to run all the sample statistics that we saw on StatCrunch just a second ago. But you need to tell it what list of information. So I'm going to say second list 1. Now if I was choosing a frequency distribution and list 1 was only containing my midpoints, then I would do comma list 2 and put in whatever their corresponding frequencies are. But I'm not. I'm doing the actual raw original data set. So I'm going to do list 1, and I'm going to hit enter. You'll see here it gives you the mean, 135.5, and so if you're thinking about the calculation, which I'll show you in a moment, how do you get the standard deviation? You take 127 and you subtract 135.5. That would be a negative value, and you'd mark that. Then you'd take 145 and subtract 135.5. Negative value, mark it. I'm sorry, in that case, positive. Anyway, so you find the difference of all these individual points from the mean, and then you find the average of those. But you can't directly find the average, which is why you have to square each of those deviations first, and then divide by n minus 1 for the sample. Anyway, I'm going to do that in a minute using the Excel program and showing you how it relates to the formula. You really probably should stay for that too. So I have all this information. I have that there's 6 pieces of data, and then here is my S. S is the standard deviation for the sample. Sigma is the standard deviation if this was an entire population. My calculator doesn't know. I know if it was an entire population or a sample. And since I know that this was a sample based on the context of the information given, that they said these were samples from students taking blood pressure, somewhere in the question, I know I'm going to read S for sample standard deviation. Oh, plus it also says it right here. But they want to know sample variance before that. Well, remember that the relationship is that the sample standard deviation, this, is the square root of the sample variance, that. Then I'm going to go work backward, and knowing this, I'm going to square to make that. So I will do 7.713, and I'm going to just put it all in because I want to be accurate. And then I can hit the square button here, or I can use the power tool here to square it. It really doesn't matter. I kind of like the looks of this one. Looks like a little 2 raised up. Hit enter, and I've got the 59.5. If I don't put in all of the number, I might get an inaccuracy here. But rounded to 1 decimal should be close enough. Let's see what happens if I do 7.7 and square that number. If I can get this decimal to react. Okay. So I square that, and that doesn't round, so you'll see that I've lost accuracy. I'm pretty sure if I would have put in 59.3, it would have docked me. It wouldn't have recognized it. Which may be one reason why 5 people missed this last semester. Okay, so what else? I want to show you something else first of all, going back to the stat, hit stat, go calc, number 1 on my list 1. If I go down, I can get other information like what the minimum is and what the maximum is, and I can take 145 and minus 127, and I didn't actually have to sort the data. So there's an advantage there. I can find the range that way. I can also find the median, 135, and I can find the first quartile, or in other words, the 25th percentile, and the third quartile, in other words, the 75th percentile. Now, if you guys did not watch the animated flowchart for the percentiles, you are missing out on a big tool. Watch the animated flowchart. Look up in the multimedia library, under the animations, look up the animated flowchart for percentiles. It clearly explains how to find them and what they are. So that's a great thing here, is that it'll run all that information similar to what we already had run. Let me see if I still have StatCrunch open. To what we had already run in StatCrunch. So you'll see that this gives you all that summary information, and the calculator here gives you all that summary information. You got to just arrow down. There's another nice feature here. If you click from the home page, the home menu, if you click second stat, go over to math, and you're using the TI-84. Now I'm not. I'm using the TI. Oh, it is also in the TI-83. I take it back. So it's also in the TI-83. You're using the TI-83. You can find the variance this way, the sample variance. You can click number 8 and then put in your list. So again, this is assuming you've already entered it and you've double checked your data. Hit it in, and it'll just calculate your variance if that's all you're looking for. And that's going to be important, because if you're taking the test and they ask you a question about the variance and you don't need to find anything else out, you can just put that in. In fact, I think you can put in, I'm going to check. I'm going to double check if I can put in the list itself. So I used the command second stats, which takes me to the list functions. I went over to math, found variance, which was number 8. And I'm typing in the data individually. And it looks like it does not take that. I think on the later calculators it does. So you do need to click stat, edit, and put the list in. But that's not too much trouble. Plus, if you're going to find any other information out about it, you want to have it in there. Alright, so that calculator is great. By the way, all the tools that I'm using, the handouts that I said are approved, give you the shortcuts on how to do this. Alright, so the last one we're going to do is Excel. I will save myself a little bit of time by choosing this little menu and saying copy table to a clipboard. So now it's been copied. And then I can go to Excel and just hit Control V, or I can hit paste or whatever. Control V is just a shortcut, so I can right click and hit paste instead. So there's my set, of course not sorted. If you want to sort here, you right click, you can go down to sort and say sort from smallest to largest, and there it goes. You do need to double check and make sure that under data, that your sort function is not choosing to treat the top one as a header. So make sure that this is unchecked. So now it's sorted and I can find my range, but here's how easy Excel is. Anytime you want to turn one of these individual cells, like let's say this one right here. You want to turn this cell into a calculator, and you don't have to enlarge it like I just did. Just hit equals and then start typing. Equals turns it into a calculator, and start typing. You can do something like 6 plus 3, and it makes a 9 there. Let me enlarge the size of these a little bit here. Or you can do something a little bit more involved, like 6 plus 3 minus 2, I don't know, times 4 divided by 13. Hit enter. Okay, so hitting equals, if you know nothing about Excel, this much you should understand. Hitting equals turns it into a calculator, and that's common for most spreadsheet programs. But what I want to do is I want to find out the range. So I just start typing in RANGE, and that is no longer available. I don't know if there's another command for it, but I don't care because I know what the range is made up of. It's made up of the maximum, so I'm going to go to maximum, and you can just type the word max and then a parenthesis, choose the list, close the parenthesis, minus the minimum. So I'm either going to click on this or I'm going to hit tab to get it and choose the same list. Make sure you choose all of the same cells. You can actually type them in A1 colon A6 and hit enter. That would be the range. Okay, what else did they ask for? They asked for the sample variance. Okay, so I'm going to hit equals VAR. Now you'll notice that they've got VARP, which would calculate the variance based on the entire population. That's sigma. And then they've got VARS, and that would calculate the sample variance. That's S. Our notation is S. And I'm using these words that I should reinforce for you from the symbols page. So let me go to the symbols page after I finish the standard deviation. So equals, standard deviation. I'll label it. And then come to the next cell, hit equals. STDEV, standard deviation. Do I want the population? No, I want the sample one. Hit tab, select, hit enter. So I'm being a little lazy in my label there. I'm going to be more specific by calling it the standard deviation. So, and those were the numbers we got, right? Now if you want them to be rounded, you can right click on it and use the significant digits tools right here. So right here I'm going to click on it. I'm going to say I want to decrease the number of decimals, and it will use conventional rounding for that. So there's 1 decimal showing for each. And again, again, those were our answers. Okay, so let me come back to this sheet and give you even more understanding. In the approved formulas and review sheets, I've got the statistics symbols list. You're going to want to learn these symbols before you can learn any of the formulas, so I will take you here first. Okay, the first page, I don't know what it's got for us. It's got a little sigma right there, which you'll notice has standard deviation associated to it, but then it's got a little r because this is expected standard deviation of ranks, and that doesn't come in until after we're already done with the chapters that we're going to do. So some of these symbols are not going to be used by the time we're done with our chapters, with our class. But they do have capital sigma. See, here's our summation right here. This means the sum of, means right here's a perfect use of it, the sum of values. It's got little n, that's the sample size, not the population size. Big N, that's the population size. Got mean. Alright, here they are. Standard deviation of a sample set of sample values. We use little s. And then a lowercase sigma, right there, lowercase sigma, is the standard deviation of the entire population. So what we wanted is we wanted this right here. And going back to the formula sheets, here's the foldout. I would expect that you'd want to bring this with you to the day of the midterm and the final on a cardstock piece of paper. Here's chapter 3. They go over all these. Look right there. They've got your sample standard deviation determined by this formula, and then they've got the shortcut. Well, the shortcut isn't much of a shortcut when we're using technology, but the shortcut would be good if we were doing it all by hand. It looks overwhelming at first, but it's actually easier to do this calculation than it is to do this calculation for bigger sets. For smaller sets, this one's actually easier, and so I'm going to go ahead and demonstrate this set right here. Okay, so let me just grab that. All right, I'll stick it right there. All right, so here's how this works. Let me insert a column right here. Shrink this one up. Okay, these are original data values, x, the list of sample values. And then what we need to do is we need to find the average. So I'm going to go ahead and put the average right here. And it's going to be calculated in Excel by just hitting equals average, choosing the set. I'll actually center both of these and just make it a little more appealing to the eye. Okay, so then what we're supposed to do in this calculation, we're supposed to take each of those values and subtract the mean from them. That's called a deviation. And that looks a little wonky, so I'm just going to remove that and just say x minus x bar, the number. Maybe I'll keep it. Okay, so to do that, I hit equals, and then I want to take this number, that's my first data value x, minus this number down here. Okay, so I'm going to hit that, and then I'm going to select it and hit F4 on my, let me show you this. I'm going to hit F4 on my calculator. Let me see if it shows you. It does not. You'll have to believe me. Okay, so I'm going to select that and hit F4. What that will do is that will fix the location of that piece. It'll fix it right there. Now you can actually just type in $A, $10, since that's the location. Then I hit enter. So I get a number, it's negative 8.5. And that's how far this is from the middle of the data set, the average from the mean. But why I did it that way is because now I can just select and paste all of those. Now this could be done by hand, pencil and paper. I wouldn't have had to sort them first, but since I did sort them, you'll notice that it's going from 3 on the negative side to 3 on the positive side. This makes sense, because if 135.5 is the average, or the mean of the set, then you'd have, with 6 numbers, you'd probably have 3 that are on one side and 3 that are on the other side, right? So don't read too much into that. I'm just saying it makes a little bit of sense. Now what we want to do is we want to find the average difference, the average of these deviations that we have. That's what this is asking for. So what we would just do normally is we just get numbers and we just divide by n how many they are, and that would be the average difference. But the problem is if we try to add these numbers up, well, let's go ahead and do that. If we try to add them up, they're going to turn out to be they're going to turn out to be 0 every time. And why would they turn out to be 0? Well, they turn out to be 0 because they're the average of all the numbers that deviate from the real average of the center. So of course they're going to turn out to be 0. Then that does nothing for us. So we can't directly find the average. So what we do is we square each of them before adding them. So we're going to take everything we have here, but then we're going to square. All right, here, there's a couple ways to do that. Here's one way. I can hit equals power, and what power does is it lets me just raise it to whatever power I choose. So I'm going to choose this number and then comma choose the power 2, second power. Now since that's been done by formula, I can scroll down and it'll do that for all of them. Or the easy way, I could have just gone, in fact I'll just deselect all of these. I can hit that number times itself. And then I can copy that all the way down. Either way, that's this part now. Okay, but how do we get the sum of all that? So the sum of all that is going to be determined by taking the sum of that list. 207 and 2500ths. All right. Just going to try to clarify here that this is the old. All right, so that's the sum. That's the top of this fraction inside the square root. And now we got to take that number, and I'm actually going to do the work right here. We're going to take that number and divide by the amount of numbers we had, which was 6, minus 1. In other words, it's 5. I'll just go ahead and type 5, but there's a formulaic way of doing that. Okay, and something's gone wrong because that number should be the same as this. So I need to check my numbers here. Let's see. All right, the first place I would check would be my sum, and I see the problem. It's only summing the first 5 numbers. So I can just select this and drop it down one more so that I'm summing from C row 2 to C row 7. Now hit enter, and this automatically recalculates for me. So why I presented it that way was for you to focus on the fact that the variance is the stuff inside the square root before we take the square root of the variance and end up with the standard deviation. But now that we want to find the standard deviation, we can just do that SQRT square root of that number right there. And that will give us the standard deviation. And this is the sample standard deviation because that's the formula that we're applying here. If we have all of the data, we can treat this as a true average that we're determining, and we would be dividing by n, not n minus 1. You should read in the text why we divide by n minus 1. It's a discussion I'm not going to go into now that I've already gone so far over time. But I'll go ahead and post this sheet also with the examples so you can play with it. You can put your own numbers in for that exact same question, in fact. And you don't feel like you have to put them in any sorted fashion because remember, these are all calculating by formula, so it doesn't really care. All right, hope this helps. It was a long video. We saw all 3 methods for determining the range, sample variance, and sample standard deviation. But then the more important stuff is not how you calculate it, because that you're going to use something to do, but what it all means. And think about why the standard deviation would be 0 if they were all the same. In fact, this is a great thing with Excel. You can just fake it. So I'm just going to copy 127 all the way down. Well, then that would mean that the average would be 127. If all your numbers were the same, the average would be that number. And then how far would each of those numbers vary from the average? Nothing. They would vary nothing. So if you wanted to find out what the average deviation was, a.k.a. the standard deviation, the average deviation would be nothing. So you can have a standard deviation as low as 0. Can you have a standard deviation that's going to be negative? That's a good question, right? Think about it. Anyway, let me reset this, and I will save this, and I will post this long video for you. Enjoy.